Welcome to our second and last lecture on quantified modal logic. This time we're going to be talking about philosophical issues with quantified modal logic. And the first problem we're going to talk about is labeled on the handout, which I will share very soon. It's called de re and de dicto. The issue of de re and de dicto is a scope distinction, at least at first pass. It turned out to be maybe more complicated than that, but we can start with the scope issue. So a scope issue is one that I think you're familiar with by now. It happens in standard first order logic as well, and it led to one of the most famous papers in the history of analytic philosophy, which is Bertrand Russell's 1905 paper on denoting. The central example in that paper was the sentence, "The present king of France is not bald." Now, the question is, when you represent that sentence formally, where do you want the negation to go? You can put the negation on the end of the sentence on the predicate being bald. And if you put it on the predicate is bald, then you're saying there is a present king of France and that person has some hair, isn't bald. Okay, so that's called narrow scope, where the negation goes as far buried back into the formal representation of the sentence as we can get. The negation might also have wide scope, which is what Bertrand Russell said. He said the negation should go out front. It's not the case that there is a present king of France who is bald. This allowed him to avoid certain metaphysical problems that plagued Meinong's view. Meinong wanted there to be a present king of France who, even though he doesn't exist, subsists in some sense. He also thought with every denoting expression, you had to have something in reality that it was pointing to. And so parts of reality exist and parts don't exist. So the present king of France subsists but does not exist. The fountain of youth doesn't actually exist, but it subsists in some sense. And this was driven by a mistaken view of denoting expressions, according to Russell. In any case, the same thing happened with modal logic. If you noticed, we were indiscriminate where we put the boxes and diamonds when we introduced the formal language components for quantified modal logic. We could put the box out in front governing an entire sentence. So we could have box for all x, fx. Or we could put the box just on the predicate. We could say for all x, box fx. Now, on the surface, it doesn't seem to make much of a difference, but Quine thought otherwise. Quine thought there were complications that arose when you let modal operators enter into subformulas in the way that we did. So let's take a look at that. That will raise the scope issue that we're talking about and help to illustrate one of the most important fundamental fallacies that occur in modal reasoning, the fallacy of, as Aquinas would put it, confusing the necessity of the consequent with the necessity of the consequence. So let me share the notes and we'll talk through the slides for a while. Okay, de re and de dicto. Here we go. Quine was worried about what we're doing when we are indiscriminate about where the operator goes. So he said there are 3 grades of modal involvement. Here's the first one. You start with a sentence, 9 is greater than 5. And then you attach a description to it. You say that sentence is necessary. So that's the first use of the language of necessity. The language of necessity in this case is a predicate that we attach to a nominalized sentence. The sentence 9 is greater than 5 in quotes is necessary. Notice that's a metalinguistic expression. It's a sentence in a language that talks about a sentence in some other language. Second, we can use the notion of necessity as an operator on a sentence. In other words, for any sentence P for a given language, we can generate another sentence of that same language by prefixing the first sentence with an operator. For example, box P. As long as P is a sentence in our language, so is box P. Now notice the slight difference between the first grade and the second grade. The second grade gives us a formula in the object language. The first grade just allowed us to talk about sentences in the object language by describing them as necessary in our meta language. That difference may not seem that significant, but it's a difference. So Quine said, well, the first grade is fine. The second grade I can live with. He wasn't really happy with the second one. He was really only happy with the first one. But in any case, let's let both of them go. So we can use the notion of necessity on parts of sentences. For example, on woofs with free variables, necessarily x is greater than 9. Or on predicates, x is necessarily greater than 5. I think I said 9 when I meant 5 for this first one. Necessarily x is greater than 5. So notice this is different than either of the previous two. The first example of modal language was metalinguistic. The second was where it became part of your object language, but it just operated, it's an operator on fully formed sentences. The third grade allows it to operate on well-formed formulas that are not full sentences. So we get those if you have free variables in a formula, and we can also attach it to parts of well-formed formulas when you attach it to the predicate. Necessarily greater than, that's a predicate, so is greater than, but necessarily greater than is a predicate. And here we have the necessity operator attaching to the predicate, not governing an entire sentence. Again, at first glance, that would seem like an innocuous difference between grades 1, 2, and 3, but Quine thought all sorts of bad things happened. Once we get to the third grade of modal involvement, where you have free variables, you can, of course, or if you had constants, you could do the same thing. You could introduce quantification into modal contexts. So if you have x is necessarily greater than 5, you can quantify in by saying there is an x such that necessarily x is greater than 5. It's this third grade of modal involvement that Quine thinks is deeply flawed. He allows the second grade, even though it rests on confusing use and mention, he said. His description was that modal logic was conceived in sin. And what he meant by that was the most obvious use of the language of necessity is metalinguistic, as when you say the sentence 9 is greater than 5 is necessary. That's metalinguistic. He thought C.I. Lewis made a mistake and forgot to notice that that was mentioning a sentence rather than using it. And so he quickly jumped to putting a box in front of the sentence, and then you get box 9 is greater than 5. And that is, of course, then an object language sentence. And it wasn't supposed to have happened because as long as you were clear on the difference between use and mention, you would have stopped at the first grade of modal involvement and not gone to the second one. Quine knows, however, that that's a bad objection to modal logic. The reason it's a bad objection is because even if C.I. Lewis was guilty of that confusion, the confusion between use and mention, and it led him to develop a modal logic in the way he did, there's nothing about the modal logic that can't be developed independently of making that mistake. It's worth noting that when Bertrand Russell talked about first order theory, he made a similar mistake. He often said things that confused use and mention when describing how connectives work and quantifiers worked in the formal system that he was presenting. The fact that people get confused by use mention sometimes is very serious, but sometimes it's just something that you could fix relatively easy, which is, of course, what we can do with standard first order theory. We just eliminate the confusion, and then develop first-order theory without any problems. The same thing is true here. We can just eliminate the confusion between use and mention, introduce the boxes and the diamonds as operators in a new formal language, and nothing problematic arises because of that. But you can't explain the third grade of modal involvement in terms of the first grade. And Quine thought the big problem here is that this leads to Aristotelian essentialism that treats some properties as essential properties and others as perhaps accidental. So what would be an example of an essential property? An essential property is one that you cannot exist and lack. So the most obvious case would seem to be self-identity. Everything is identical to itself and not another thing. That's what Bishop Butler said. Sounds like something true. So the property of being identical to yourself is one that you simply could not exist and lack. Other properties you can. Your height, you didn't have to be exactly that height. Your weight, your hair color, your eye color, who your friends are, all sorts of things didn't have to be the way they are. So they pick out accidental properties. All of that seems straightforward, but Quine thinks this idea of Aristotelian essentialism is thoroughly confused. As Quine puts it, necessity resides in words, not in things. So anything that's necessary is necessary because of the words we use to describe it, not because the necessity is found in the thing itself, as Aristotle thought. So why does Quine think necessity resides only in words? Here's his argument. So you have to be a little charitable with Quine about this because you're going to balk at all of these claims. But here's some candidates for ways to talk about necessary and accidental properties. You can say, for example, humans are necessarily rational. Aristotle thought that was a defining characteristic of human beings, was rationality. So suppose you agree. You say humans are necessarily or essentially rational, but they're not necessarily two-footed. They are not necessarily bipedal. Cyclists, on the other hand, are necessarily bipedal, but not necessarily rational. Carl is a human cyclist. So Carl, Quine thought, would have to be both necessarily rational and not necessarily rational, and both necessarily bipedal and not necessarily bipedal. Okay, that's the argument in quick form. You can see what happens. If you distinguish between essential properties and accidental or non-essential properties, it turns out you can find one individual that falls into two groups that are defined by different essential properties, and then a contradiction quickly ensues. Don't object to this argument by quibbling with which properties Quine picked. For example, do cyclists really have to have 2 feet? No. You can ride a bicycle with just 1 foot. In fact, it's a well-known training exercise for Olympic quality cyclists that you take off one of the pedals. You don't take off the cyclist's foot, but you take off one of the pedals and you make them ride the bike with just one leg at a time. So suppose you're a human being that was born without one of your legs. Could you ride a bike? Of course. I mean, it would be hard. So we could quibble about that example. We could quibble about whether humans are necessarily rational. Think of the kinds of cognitive defects that plague some births in the human species. So you can have human beings who are born that don't even have measurable IQs of any sort at all. They're not capable of thought. Are they necessarily rational? And no. In fact, they're not rational at all. Are they human? Pretty obviously, they are human. At least let's go with that. So we could quibble about the particular properties that are being selected. But if the idea is that there are some essential properties of things, kinds of things, then we're going to quickly end up with a contradiction. So if humans have some essential properties and cyclists have different essential properties, then when you find a human cyclist, you should be able to generate the very same contradiction with better properties chosen that don't lead you to quibble about whether the property is really essential or not essential to the kind of thing in question. Okay, Quine's lesson from this argument is that, as he puts it, necessity resides in words, not in things. And notice that takes us back to the first grade of modal involvement, where what you're doing is you're predicating a property of necessity of a sentence. And it's the particular words that you choose in formulating the sentence that determines whether necessity is present or absent. There are other cases of this as well, one that we'll come back to. It's not clear how many planets there are. It's been a little up in the air, but it seems like there's 8 instead of 9. But philosophers, when they were writing about this, everybody assumed it was 9. So 9 has certain essential properties. It is, for example, 3 squared. It essentially has that property. It could not lack that property. The number of planets, on the other hand, doesn't have that property essentially. It may have that property if there really are 9 planets, but even if 9 is the number of planets, it didn't have to be that way. So the number of planets could have been something other than 3 to the power of 2. So in this case, if there are 9 planets, both terms, both the number 9 and the number of planets, 9 picks out something that is odd, and presumably it picks out something that's necessarily odd. But the number of planets isn't necessarily odd. It could have been other. Let's take a look more closely at Quine's argument, however, because it's a good example of a scope fallacy regarding modal reasoning. So Quine says that humans, let's give him the claim that humans are essentially rational and not essentially bipedal. We won't quibble over the particular properties that he picks. Let's now try to represent each of these 2 claims. And here you have a box operator to be put somewhere in the sentence, and you have to pick where the box operator is going to go. Just like with the case of negation for the sentence, the present King of France isn't bald, we have a choice about wide scope or narrow scope for the necessity operator. So here is the wide scope reading. The wide scope reading says, it's a necessary truth. It's necessarily true that for all x, if x is human, then x is rational. And it's not necessarily the case for all x that if x is human, then x is bipedal. That's the wide scope reading. The narrow scope reading puts the box at the back end of each of the sentences. So that says for all x, if x is human, then x is essentially rational. And for all x, if x is human, then x is not essentially bipedal. Those are the different ways in terms of scope to read those. And that came to be called the de dicto and the de re reading. The top one, the de dicto. De dicto is because the Latin word for sentence is dictum. So there the necessity is governing an entire sentence, a well-formed formula with no free variables in it in our first order language. Same thing with the second one, with the second part of the first one, which I will highlight, that one. That one too is a de dicto attribution of necessity. If you want, you can convert it to a possibility claim, and then you'll get, it's possible that there exists a human who is human, that there exists a human who's not bipedal. Once again, the modal operator governs an entire well-formed formula with no free variables. In the second case, though, it attaches just to the back side of the formula, and so it is not governing an entire sentence. It is rather governing a part of a sentence. De re means in Latin of the thing. So what it says is we are now predicating modality of the thing X itself. We are saying X has a certain necessary feature, being rational, and lacks a certain other necessary feature, being bipedal. Note that on either of our semantics, either fixed domain or variable domain semantics, the positive claims about rationality don't quite work. Each of us could become incapable of thought, and some humans are born without mental capacities necessary for rationality. That will plague almost any example we come up with, so we are just not going to do that. Now, let's think we are going back to these two readings, and what we really want to know is which of these, or maybe both of them, are ones that we should endorse if we grant the point that rationality and being bipedal have the features that would make Aristotle happy, so that rationality is essential, but being two-footed is not. Here's some translation examples. This is one of Quine's favorite ones. Your yacht might have been bigger than it is. Now, there's a reading of that on which such a remark is senseless. The senseless remark is you take your yacht, you figure out what size it is, and you say it's possible that the size is different from the actual size. It's possible that the size is something else. Here's another one. Some rich person might have been poor. Nobody can be both rich and poor. Your yacht has a size, and that size is not bigger than it is. So there's a reading of these sentences that makes them out to be goofy, even though it's pretty clear there is a sensible sense of the sentence. Every bachelor is necessarily unmarried is another one. Now let's start with that third one. Every bachelor is necessarily unmarried. There is a way in which that sentence can be understood to be true. To get it to come out true, you better be moving the box outside of the entire sentence. You better be saying necessarily for all X, if X is a bachelor, then X is unmarried. If you move the necessity operator to the back part of the sentence, then you say you're going to pick a bachelor. Who's a famous bachelor? Hugh Hefner used to be a famous bachelor. Let's use him. So Hugh Hefner was a bachelor. And now, is it true that Hugh Hefner had the essential property of being unmarried? Of course not. It's easy to imagine a world where Hugh Hefner exists and is married. So it's not the case that in every world in which you find Hugh Hefner, you find him unmarried. What is true is that if he's married, he's no longer a bachelor. But you couldn't get that he's necessarily unmarried, that he's essentially lacking the property of being married unless you could get that he's essentially a bachelor, which you cannot get. He's not essentially a bachelor, and so he's not essentially unmarried. So if you want the sentence to come out true, you have to put the necessity operator out front and read it as a de dicto necessity. You have to read it as necessarily for all X, if X is a bachelor, then X is unmarried. Now, the same de dicto, de re ambiguity occurs with the top two. I'll let you figure out, and you can email me about this if you can't figure it out, but figure out what the de re reading is and what the de dicto reading is. And one of the two will make the sentence look stupid, and the other one will make it look sane, something that a person might actually say truthfully. So some rich person might have been poor. You don't want the possibility operator outside governing the whole sentence, because then you'd say, it's possible that there exists some person that is both rich and poor. That's not what you meant. What you meant is there is a person who happens to be rich and was possibly poor. Notice that pushes the possibility operator to the end of the sentence, to the de re position. So depending on whether you read the sentence, hear the sentence as a de re or a de dicto necessity or possibility claim, the sentence can look true, be true. In the other case, it just looks goofy. It looks totally implausible. I'll let you figure out what you say about the yacht and its size. Something similar to what I said about the rich person and the poor person will apply there as well. Basically, you want the de re reading. That's the one that sounds true. The de dicto reading makes it look goofy and silly. Okay, so go back now to what Quine said. Humans are necessarily rational, but not necessarily bipedal. Now, the first one, humans are necessarily rational, you probably are willing to grant it in both de re and de dicto forms. So it looks like you will want to say about that, it's a necessary truth that if you're a human, then you're rational. Or at least it would be if Aristotle was right about the defining characteristics of humans. You might also say, well, if you're a human, then you have a certain property essentially. Now, I think the reason you're tempted to say that is because you may be tempted to think that any human being is essentially a human being. That if you're a human being, you could not exist in any world and fail to be a human being. If that's true, then embracing the de dicto reading of the sentence will commit you to the de re reading as well. Because if you remember, boxes distribute across arrows. That's called the distribution axiom. So if you had box, parentheses, P arrow Q, you could infer from that box P arrow box Q. So take a look at the de dicto reading. Here, suppose you think, yeah, I agree, that sentence is true. Necessarily, everything that's human is rational. If you also think everything that's human is essentially human, you can infer the de re reading, because notice, in some sense here, with quantifiers mixed in, you have a box governing an arrow. So you should think, yeah, you can get this. You could also get for all x, box hx, arrow, box rx here. But if you don't think that you are essentially a human being, or if you don't think that you have to be essentially a human being in order to be a human being, then you can't get the de re reading. The de re reading will come out false. So for example, suppose you are a human being and you don't think you're essentially a human being. You think you might have been a great ape, or maybe you think you might have been a dog, or maybe you think you might have been a worm. Notice that religions that teach reincarnation are committed to such claims. You were at some point a different kind of being. So you're now a human being, but you're not essentially a human being. If you're not essentially a human being, then the de re reading sounds absurd, right? You pick out a human being and you say, okay, we've got a human being. Used to be a dog in a former life, but that would have been a rational dog because the human being is essentially rational. Notice that's as absurd as the de re reading of the claim about the bachelors being necessarily unmarried. Hugh Hefner is in fact a bachelor, or was a bachelor when he was alive, but he wasn't essentially unmarried. He just happened to be unmarried. So unless you think human beings are essentially human beings, you can't get the de re reading. This becomes even more obvious with the other readings. So take a look at the claim about being bipedal. Is it possible for there to be a human being who's not bipedal? Of course. Is it true that every human being fails to be essentially bipedal? Well, you may worry about that. You may grant it. Some of you will grant it. Maybe it's not true. I know in general, human beings are not essentially bipedal, but who knows? Maybe there's a special human being, and that individual could not exist without having 2 feet. I don't know that that's true, but it's certainly compatible with our general judgment that human beings are not necessarily bipedal. What that means is the most plausible readings of Quine's premises are the de dicto readings. But notice you don't get the contradiction that he needs without the de re readings. So the ones that are the most plausible are the top 2 readings. The ones that he needs to derive his contradiction are the de re readings. I will leave that as a proof for you to send me, if you wish, to show why Quine needs these 2 readings in order to derive the contradiction that he claimed in the argument here. He claimed that Carl is a human cyclist, so he's both essentially rational and not essentially rational, both essentially bipedal and not essentially bipedal. That's a contradiction if you hear the word, I'm using the word essential rather than necessary. I want you to hear the language of what's essential in terms of the narrow scope reading of the modal operator. So it is on the backside of the sentence attached to the property itself. The de re readings were the least plausible of the readings. The de dicto reading was the one that makes it sound like you said something true. But you can't get this contradiction about Carl without relying on the de re readings. So Quine is guilty of a mistake. The mistake in medieval times was well known, and it was described in terms of sentences that we now represent this way. Remember, I said Aquinas called this the fallacy of confusing the necessity of the consequence with the necessity of the consequent. Now remember, the consequent of a conditional is the stuff after the arrow. So the necessity of the consequent is that reading, the de re reading. The necessity of the consequence is where you have a box governing a consequence relation, the arrow. So the top one is the necessity of the consequence. The bottom one is the necessity of the consequent. And it's very easy to hear a sentence in ordinary English, such as humans are necessarily rational. It's very easy to hear that sentence as coming out true, but you have to be careful which of the 2 readings you're relying on when you're constructing arguments from them. That is probably the most famous modal fallacy in all of the history of philosophy and modal reasoning. Second problem is whether identity is necessary or not. And for a long, long time, people thought, well, sometimes it is, sometimes it isn't. So remember, one of the theorems of quantified modal logic and standard first order theory is A equals A. A equals A is a theorem. And in modal logic, one of the first things we learned is that if you have a theorem, you can put a box in front of it. So you've got A equals A, and then you put a box in front of it. And that looks like it says necessity applies to identity claims. So identity is necessary. But there are examples that seem to suggest that identities don't have to be necessary. They could be contingent. So here's some sentences. Ben Franklin is the inventor of bifocals. I don't know if you knew that's true. It is true. 9 is the number of planets. That's not true. It's supposed to, I think it's 8, but it doesn't matter. We're looking at the copula. The word is. How are we supposed to interpret this word in these sentences? So Ben Franklin is the inventor of bifocals. 9 is the number of planets. The sentence is false, but how are we supposed to understand it? Scott is the author of Waverly. The morning star is the evening star, or sometimes it's said Hesperus is phosphorus, but we'll go with the morning star is the evening star. Now, it is well known that the verb is, or any other variant of the verb to be, is ambiguous between different readings. One is sometimes referred to as the is of predication. My dog is a beagle. That's not asserting an identity between my dog and the kind of dog that's a beagle. It's just saying my dog has a certain property. The is of predication is one that we are all comfortable with. And we usually represent that if we have A is F, where F is a predicate and A is a constant, we treat the is F as an is of predication. And so we represent it as capital F, lowercase a. That's the is of predication. But there are other cases where is looks like it's the is of identity. So 2 plus 3 equals 5. We could say that using equals. That makes you think of the symbol for equality. We could also say 2 plus 3 is 5. Now there, the is not the is of predication. It's stronger than that. It's saying that in some sense, 2 plus 3 is the same thing as 5. Now, look at the sentences here. Are these examples of the is of predication or the is of identity? People thought, no, it's not just the is of predication because it's stronger than that. Benjamin Franklin is a citizen of Philadelphia. That's an is of predication. But this is different. This is saying we have two phrases flanking the verb is, and they pick out the same individual. It's supposed to work exactly like Samuel Clemens is Mark Twain, or Superman is Clark Kent. Those are identity claims. It's just in this case, we have Benjamin Franklin, which is a name, and then we have a denoting phrase, the inventor of bifocals. They pick out, they refer to the same individual. So the claim we've got here is an identity claim, but it's not a necessary truth. Ben Franklin didn't have to invent the bifocals at all. In fact, there didn't even have to be an inventor of bifocals, or it could have been somebody entirely different. Same thing with 9 and the number of planets, Scott and the author of Waverly, and even the most important discovery in early astronomy that Venus is both the morning star and the evening star. So the morning star is the evening star. All of those are identity claims. They're not predications. They are identity claims. That's the idea. So they give us examples of identity claims that are not necessary identities. They are contingent identities. Well, along comes the star of modal logic, Saul Kripke. Here's a proof that identity can't be contingent. First principle, the substitutivity of identity. For all x and y, if x and y are identical, then if x has a certain property f, so does y. This second one, the essentiality of identity, is just the generalization of the fact that I reported earlier. A equals A is a theorem in standard first order theory. By the rule of necessitation, we can box it, so we can get box A equals A. And then since that's a theorem, you can universally generalize on it. So for all x, it's a necessary truth that x is identical to x. Now, this looks complicated, but it's actually just a substitution instance of 1. What we do is we take this property, being identical to itself, as the value for f. Let f be this property, being necessarily self-identical. And then substitute in that formula for f. So start out for all x and y, if x equals y, then box x equals x implies, and notice what we did. We took box, here's the property that x has in the second sentence. X has the property of being necessarily identical to x. So we put in place of f, box, parentheses, x equals, and then we attribute that to x here. We put in box, open parentheses, x equals, and that's a property that x has. And if x has that property, so does y. So notice we put in the same string of symbols, if this will highlight what I wanted to. We put in, I think you see what I'm trying to do. I'm trying to highlight the box, the open parentheses, the x, and then the identity symbol. I put that in the same position in place of f, both here and here. So this third claim is an instance of 1. And notice what it says. For all x and y, if x is the same thing as y, then on the assumption that x is self-identical, on the assumption that the identity of x with x is necessary, then the identity of x with y will be necessary as well. And this little antecedent is already a theorem, as we saw here. So it can just drop out. Once we drop it out, because it's a theorem and couldn't be false, we end up with this. For all x and y, if x is identical to y, if x is identical to y, then it's necessary that x is identical to y. So, Kripke claimed, identities simply can't be contingent. So if you go back to these claims on the previous page, none of those claims could be true if they're read as identity claims. You would have to interpret them in some other way. So what do you want to say here? Do you want to deny that those sentences that seem to be identity claims really are identity claims? Do you want to say Ben Franklin is in fact the inventor of bifocals, but that's not an identity claim? And the same for all of the others. That's one option. You have to say more though if you take that route. You better say something about how you understand the class of identity claims. When do you have one and when don't you? Kripke did that. He used the language of a rigid designator. He said, we have these denoting terms in natural language. We have things like proper names, we have things like definite descriptions. They refer to things. The phrase, the Empire State Building, refers to a building. The name Superman refers to a thing if it manages to designate at all, but it's the kind of linguistic item that aims to pick out an object. In this case, a fictional object. So I don't know what you want to do with fictional objects, but let's just say for now it picks out a fictional object. Kripke said some of these referring expressions are rigid designators and some aren't. So he said, a term that picks out the same thing in every possible world, if it picks out anything at all, is a rigid designator. So Donald Trump, the name, that term picks out the same thing in every possible world. So suppose you think there is a possible world in which Donald Trump is a stable genius. I don't care what possible world you think that is, but notice how you interpret the truth conditions for that. You go find a world, and the first thing you do is you figure out who Donald Trump is. Is that the same person that we're talking about when we talk about Donald Trump, the 45th president of the US? Yeah. So Donald Trump is a rigid designator. And Kripke said ordinary proper names work just like that. They are rigid designators. Okay, fine. That's good. Notice that involves a certain assumption about what names are doing. There are cultures in which you get named something that has descriptive content and is supposed to be telling you something about your character or something about your history or something that happened to you. One who soars with eagles, that could be a name in various Native American contexts. Are those going to be rigid designators? That's worth thinking about, but probably not. Think of the movie Kevin Costner, Dances with Wolves. He was given a name, assigned a name by the Lakota Sioux. And when they asked him, when he asked what the name meant, they said one who dances with wolves because they saw him dancing with a wolf. All right, that's not typically the way we do names. You didn't name Donald Trump because of something about his character. It's just a tag. So that's what Kripke said. You're going to get identity claims that can be true only when you get rigid designators on both sides. So Ben Franklin on one side of that equality symbol, that would be a rigid designator. But the inventor of bifocals is not a rigid designator. In this world, that term picks out Ben Franklin. You go to some other world and it picks out either nobody at all or some different person who beat Franklin to the task. So it's not a rigid designator. And so if you treat that as an identity claim, it will be a false identity claim. So it's better to treat it more in the way we treat predications in general rather than identity claims. So Mark Twain is Sam Clemens. That's a true identity claim. Cicero is Tully. That's another true identity claim. What's interesting is Phosphorus and Hesperus seem to be names. And so Hesperus is Phosphorus seems to be a true identity claim, whereas the morning star and the evening star both seem to be descriptive claims of a certain sort that wouldn't count as rigid designators. And so that won't be an identity claim, even though Hesperus is the morning star and Phosphorus is the evening star. Not surprising though, since definite descriptions typically tend to be non-rigid designators. Okay, so the second problem is, do we really want to throw out all contingent identities, or do we want to salvage them in some way and claim that Kripke's argument has a mistake in it? Third problem. Now this I already went through when we talked about the difference between fixed domain semantics and variable domain semantics. And I said at the time that variable domain semantics seemed preferable precisely because it didn't commit us to having the same domain in every possible world. So here's an informal proof relying on a fixed domain semantics for a Barcan formula. Notice the difference between the Barcan formula on the left, the part of the formula on the left and on the right just has to do with the scope of the box. This is narrow scope, this is wide scope. The claim says I can infer wide scope from narrow scope. So assume that everything is essentially F. And also assume that the consequent is false, that it's not necessary that everything is F. Now apply the dual rule to line 2, and then you can prove this, but I'm just going to do it in one step. We can go from diamond not for all to diamond there exists an X such that X isn't F. It's possible that there exists something that is not F. That's what this assumption commits us to. So in some world, something is not F. So assume that it's A that makes this true in that world, not FA is true in some world. An instance of the first assumption for all X, box Fx is box Fa. That's how universal elimination works. So in every world, Fa is true, contradicting the immediately preceding line. That's a proof of the Barcan formula. Now, as we saw when we did fixed and variable domain semantics, you can avoid that result by not insisting that each world has the same domain. So let FA be false at a world because A isn't a member of the domain for W. And let FA be true in every world in which A exists. By doing that, we can get the variable domain semantics to generate a counter model to this Barcan formula. All right, we already saw that when we went through variable domain semantics in the technical parts of quantified modal logic. So is that pretty cool? Yes, it is pretty cool, except look at this. It's something weird happens even if you endorse variable domain semantics. And that's because A equals A is always a theorem. It doesn't matter what A is. Well, then so is the existentially quantified version of that. There exists an X such that X is identical to A. And if that's a theorem, we can put a box on it. This last claim, though, looks like it says that A is a necessary being, and nothing in the argument is affected by a choice of constants. So we can generalize for all X. It's necessary that there is some Y such that Y is identical to X. And that looks like it says everything is necessary. Everything is necessary. And that's what it looked like the variable domain semantics was supposed to allow us to get out of. So what should we do here? What restrictions, how do we avoid this argument? Because we don't want to say, if you're attracted to variable domain semantics, it was because you don't think everything is a necessary being. So if you want to reject the conclusion, you have to reject one of the premises. I will tell you that the standard step to reject is the rule of necessitation. The rule of necessitation works perfectly fine for propositional logic. Anytime you've got a theorem in propositional logic, you can put a box on the front of it. But maybe you have to insert restrictions on it when it comes to modal contexts where you're using quantified predicate logic with modal operators in addition. So this is unquestionably a theorem of first order logic. And because it is, so is this claim. You're stuck with those two unless you start revising standard first order theory. Notice if you were attracted to free logic, there's a version of free logic on which this is a theorem, but this is not, right? A equals A comes out true for systems where you have a semantics that has dual domains, one of things that exist and one of things that don't. So this will be a theorem if it's in either one, if A is in either the set of things that exist or the set of things that don't. And if it's in the set of things that don't, you can't existentially quantify it. So free logic would allow you to stop this argument between step 1 and step 2. But if you don't endorse free logic, if you stick with standard first order theory, you're stuck with both of these first two steps. So it looks like the place you're going to have to balk is to say, we're not going to be able to attach the rule of necessitation because if A is a contingent thing, there will be something that it's identical to, namely itself, and that'll be a theorem, but you're just not going to be able to box theorems when A is a contingent thing. And there's been quite a bit of literature written about how you're supposed to do that. What exactly, if you're going to restrict the rule of necessitation, what are the restrictions supposed to be? Okay, that's the third complication. Here's the last one, the question about actualism and possibilism. So one way in which that question has come up is we're talking about both the actual world and the possible world. And that might make you a little uncomfortable. You might be inclined to think, well, the actual world is real. Possible worlds are inventions. they're not real, or they're not as real as the actual world. So can we do things to avoid talking about possible worlds? That's one way in which the question of possibilism comes up. Perhaps there's no way to do quantified modal logic or modal logic in general without talking about possible entities. If we could be more realistic, it would be preferable if we didn't have to do that. If we could say, look, all there really is what's actual. That's it. There's nothing that's not actual. If a thing has any reality at all, it is an actual thing. All the rest is mere inventions. Okay, how is that supposed to work? Well, suppose we do it this way. If you remember when we did free logic, we sometimes allowed there to be a domain of things that don't exist. So we had a domain of things that did exist and a domain of things that didn't exist. And it turned out that the two domains couldn't overlap, which should be obvious from the way that we described them. But suppose we do the same kind of thing without the non-overlap requirement. So suppose, if you remember how we did variable domain semantics, we said, well, you've got a superdomain. And then you've got a subset of a superdomain for each of the worlds. That's the domain for the world. We wrote it as D sub W. The domain for the world is a subset of the superdomain. And that allowed us to describe how worlds could have different things in them. Okay, fine. The quantifier then inside of a world always ranged over the domain for that world. But once you know how quantifiers work, why don't you just introduce a new, fully general, totally unrestricted quantifier? Let's subscript the universal quantifier with a little p. The little p stands for possibilia. So we're going to quantify over everything in the superdomain. We're not going to just quantify over things within the domain for the world that we're thinking about. So we now have a totally unrestricted new quantifier in our language. If so, we can still get the necessity of something existentially quantified, since we'll be able to prove this. For all possible x's, it's necessary that there's a possible y such that y is equal to x. That will be the analog of this formula when we were quantifying only over objects instead of things in the superdomain. To see why, consider the valuation clause for this quantifier. All right, when does a formula get assigned a value of 1 at a world? You've got to have a model, and you have to have this function that assigns temporary objects to free variables in the formula if there are any. Let's just assume that there aren't any so that this does no work. So for each u in the domain, now notice that this big D domain is the superdomain, not the subset of the superdomain for the world W. That fits because our quantifier is supposed to be ranging over everything in the superdomain. So for every object in the superdomain, the valuation function relative to the model assigns 1 to the formula with the quantifier removed at that world, where any variable is replaced with some member u of the domain. Okay, that's the valuation clause. It's standard except for the things that you change to accommodate the fact that you've introduced a new quantifier. It's exactly like the clause for the universal quantifier in variable domain semantics, except that D is replaced with the D sub W, which is the subset of the superdomain for world W. Okay, fine. What does our formula actually say in ordinary English? The one that we're going to be able to prove given this valuation clause. Maybe it says this: all possibilia are necessarily identical to some possibilia. Is that okay? We are now quantifying over possibilia, and one of Quine's famous sayings is that to be is to be the value of a bound variable. Now, Quine, of course, when he talked about variables, was thinking about the variables of standard first-order theory. He wasn't imagining this newly introduced, fully general, totally unrestricted quantifier over a superdomain. But once you have such quantifiers in the language, the bound variables will include all possibilia whatsoever, anything that's a member of the superdomain. And then it looks like we're committed to including possibilia in our ontology. If you go with Quine and you allow the introduction of this new quantifier, that's what you're stuck with. But then when you started out with this idea that we only want to countenance what's actual when we talk about what reality includes, we end up being unable to sustain that. We end up saying all of reality includes everything in the superdomain, and lots of stuff in the superdomain does not actually exist. But it is nonetheless real. So call that a bifurcated ontology. It's an ontology that has two parts to it: the stuff that exists and the stuff that doesn't, or the stuff that doesn't exist but is nonetheless possible. At least it looks like this is an argument you might have to go down that road. You may also have to go to more insane lengths, because once you introduce stuff that doesn't exist but is possible, you might wonder why you're excluding stuff that doesn't exist but is impossible. Why don't you have that sort of stuff in your ontology as well? Well, because that sounds nuts. That should be your first thought and your first response. That's crazy. In my ontology, even if I'm forced to include stuff that is possible but non-actual, I don't want to also have to include stuff that's impossible but non-actual. But things get very complicated once you start thinking about the philosophical implications of the semantic account you prefer when you do quantified modal logic. So Quine is vindicated in one sense. There wasn't anything fancy or difficult that arose because of standard modal logic at the propositional level. Once you turned to quantified modal logic, you introduced some options: fixed domain semantics, variable domain semantics, and no matter which version you accept, it looked like some bad things were going to happen, or at least some questionable things were going to happen. Quine thought you just landed yourself in contradictions very fast, but it turned out there was a really simple, straightforward explanation appealing to de re and de dicto necessities to handle that. But once we got past Quine's initial objections, people started thinking about things: the question of the necessity of identity and whether there are necessary beings. And the deepest, most general worry of all is, what are we really committed to when we start describing the constituents or elements of reality? What does reality encompass? And people that have healthy senses of reality, as Russell termed it, people with healthy senses of reality don't want to countenance elements in their account of reality that go beyond what's actually in reality. What's actually there is all you need. You don't need stuff that's non-actual but possible. You don't need a bifurcated or trifurcated or some other higher numbered furcated term. I don't even know what that would supposed to be. quadricated. Could you have that? I don't know. In any case, you just want there to be actual stuff and nothing more. So there are deep ontological questions attached to quantified modal logic about whether you can defend actualism or not. If any of you are interested in it, the most detailed and wonderful discussion of the question of actualism is in the Stanford Encyclopedia of Philosophy by a former colleague of mine. Actually, we went to grad school together. Christopher Menzel wrote a beautiful, superb account of the issues and problems for the Stanford Encyclopedia of Philosophy. And the title of it is called Actualism. So if you're interested, take a look at that. If you get interested enough that you want to think about it or write to me about it or whatever, I'd be happy to give extra credit to anybody.